Welcome to solverfy.
Cars are colliding. The first car is moving to the east. And the second car is moving to the south. So when they collide, they stick together, and we have to calculate the velocity after the collision and change and loss, relative loss in the kinetic energy. Let's do this. So first, let's sketch this collision. So at the collision point, the first car had a momentum of m1 v1, or let's write it down as p1, and the second car had a momentum of p2. They are directed as shown here. Now we can introduce y and x axis, and we can write down the conservation of the momentum. So vector sum of p1 and p2 equals to p3, which is momentum after the collision. In terms of here, we just need to calculate the sum of these two vectors, and this is the resulting vector, which is the diagonal of this right triangle, because p1 and p2 are perpendicular. So p3 is shown here. Let's presume that this angle alpha is angle with the east direction. And we can calculate this alpha now. Alpha equal from this triangle, alpha equals to a tangent of p2 over p1, or it equals to a tangent of m2v2 over m1v1. Let's calculate it numerically. It equals to a tangent of m2 times v2 divided by m1 v1. So let's calculate this number. It is 46.6 degrees. So therefore it's 46.6 degrees to the south, to the east direction. Basically this angle is to the east direction, in the east-south quadrant. Okay, we found the angle alpha. Now we have to calculate the velocity after the collision. So this velocity u equals to p3 divided by m1 plus m2. And as we can see from the triangle, p3 is a vector sum of p3 equals to square root of p1 squared plus p2 squared. So therefore p3 is square root of m1 v1 squared plus m2 v2 squared. And it's all divided by the sum of m1 and m2. Now let's calculate u. It equals to, in the denominator it is 1500 plus 1800, and the denominator we have 1500 times 17 squared plus 1800 times 15 squared, and it's meters per second times kilogram. Now let's calculate the result. It equals to 11.25 meters per second. Let me rewrite it more accurately. 11.25 meters per second, which is roughly 11.3 meters per second. So that's the solution of question A. Now let's solve question B. Here, let's calculate the change in the kinetic energy. It equals to initial kinetic. Yeah, here we're calculating the absolute change. So it's the difference between the initial minus final. Initial kinetic energy is m1 v1 squared over 2 plus m2 v2 squared over 2. And the final is m1 plus m2 times u squared over 2. Okay, let's calculate K1. K1 is m1 v1 squared over 2 plus m2 v2 squared over 2. Or it is 1500 times 17 squared over 2 joules plus m2, which is 1800 times 15 squared over 2, also in joules. Now we can calculate this number. It equals to the following: is 419,250 joules, right? Yes. Now we can calculate delta K. So delta K equals to this number minus m1 plus m2, which is 1500 plus 1500 times 11.3 squared joules. Now let's calculate this number. it equals to the following: 208,562 joules. So then delta K over K, let's express it in percent, equals to 49.75%. So that's the solution of this problem. I hope I helped you. Thank you very much for your attention. Bye.